on my side, typically when I do a project which use the MTConnect, first of all, I need to do is to define the MTConnect agent device XML, right? That is the, well, typically what I do is that from the GitHub or the other, example from the Majak demonstration or the list, I believe this is deprecated now, right? Anyway, so
Yep.
I copy that device XML typically, and then I look into the system structure. My basic assumption is that the reference device XML is correct and it follows the standard, right? And then if I need to add additional data item or the data type, I need to look into the PDF document. So the biggest thing for me is to generate the device XML which follows the standard well. And then typically I use the Python or Ruby for the MTConnect adapter. Well, the biggest thing to me is that to define the device XML. So if I could use your transpiler C# library for that purpose, I think that is really awesome because I can customize my device, not the device, the MTConnect adapter, but the main constraint is the device XML. So that means if device XML is wrong, my following work will be wrong.
Yeah. Okay. So with that being said, instead of reinventing the wheel and using the transpiler to help you write an adapter, you can utilize libraries that have already done transpiler to provide an SDK. So in this example, TAMS has open sourced this adapter SDK library, which is a C# library, to simplify the development of MTConnect compliant adapters. And what I think is really relevant to your end goal, which is to produce a compliant device configuration file, this adapter SDK is capable of generating that model in memory and communicating that model directly to an MTConnect agent. And we worked within the Institute to open up an endpoint in the reference agent to pass that model back and forth between the adapter and the agent. So
ENSIV has seen that with our FANUC adapter. But I think he probably doesn't necessarily know how to use our adapter SDK to enable that for another project that maybe he has. So I think, reviewing maybe how to use the adapter SDK could be useful, and then also reviewing the Think Composer, how to build a model from Think Composer, because with what you did with the transpiler there, I think that would be very, very relevant and helpful.
Okay. Yeah, so just to briefly start off with the SDK, and to kind of drive the point home is that, again, instead of creating your own transpiler and trying to, learn how that works and how to use it, you can utilize existing transpiled solutions. So this adapter SDK uses a transpiler to automatically generate a bunch of these classes and interface and enums directly from the standard. So you can see here in this SDK, there's a full list of all the types and subtypes that you can reference in your adapter, and it's fully documented. It's synonymous with the standard. There's links to the model browser. It's a very comprehensive SDK that you can reference. I guess in practice, I can try to pull up a MakerBot example. Bear with me for just a sec. Okay, so this MakerBot MTConnect adapter uses the SDK to simplify the development of the adapter. So what I have primarily in this solution is I have one project that is dedicated to understanding how to connect to the machine itself. A lot of times there's already an existing SDK. In this case, there's no library publicly available to connect to a MakerBot. So I had to kind of come up with one on my own. The next project is a really small project. There's only 2 classes, really. There's basically the model that represents the machine and the logic to make a connection to the machine and then populate the fields of this model. Does that make sense?
Yes.
So all of these interfaces are taken from the SDK. It provides a framework for when to start a connection to the machine and how to update and send the data to an agent. And there's just one line of code that will send all the data to the machine or to the agent. Find that, yeah. So when you have an update to the data model, you just call this method, and it will send the data to the agent. Right? You don't have to worry about following the shutter protocol, and formatting all the different strings for sample versus time series versus events and conditions. That's all handled under the hood for you. When it comes to describing the model of the machine, it's a very object-oriented approach. I start off way down here towards the bottom where I have a MakerBot machine, and I'm using the SDK to indicate that this is a model that can be reflected upon in the SDK, and I want you to label all these properties as an event, but specifically it's the availability event as defined by the MTConnect standard. So I can I have an apples to apples relationship between my C# code, my implementation for this device model, and the standard. This also includes like deprecated items. So if you're trying to use, I don't know if I have an example of this. John, what's an example of a deprecated data item?
I had amperage before, but I doubt you're using that in there.
Well, let's just add it.
Amperage became amperage AC and amperage DC.
So I have amperage. So power to head. So let's say I wanted to incorrectly add this amperage to my device model. Oh, this is technically deprecated, so I'm going to get a compiler warning now because I'm using a deprecated data item. And when I hover over this, because this is all transpiled, I have a full documentation of why it was deprecated. I can click on this link and I can look for amperage, and I don't know, maybe in the future they'll add another column here for why it was deprecated. But that's kind of the beauty of using transpiled code.
I see.
So maybe another meeting we get on where we could go through and like build a example MTConnect adapter with our adapter SDK
Mhm.
and show you how it'll basically from modeling the device in this object-oriented manner with the transpiled code, we're able to automatically generate the MTConnect device XML. The device XML just becomes a device model in memory, and we could transmit the adapter SDK will use that communication channel between the adapter and the agent to transmit the model to the agent. So if you use our adapter SDK, or if we kind of go through an example of how to use the adapter SDK, you could enable the same functionality that I showed you with the FANUC adapter, where it basically will just send the model and you don't have to deal with the XML.
Mm-hmm. Yeah, so all of this that you're seeing here is automatically from an adapter.
So is one of your end goal to eliminate the device XML by using this library?
I don't know that it's necessarily a goal that we set out to do. I mean, it's the goal has been to simplify implementations for us, and I think as a product we've kind of eliminated the need for like an engineer to work with these device files.
I see.